This is the last section in Unit 6, so there's only 4 sections in this unit, and these are hyperbolas. So it's going to start out very similar to ellipses, and there's going to be some slight differences between ellipses and hyperbolas. It's a little bit more complicated, but not much. So we're still going to have vertices, but now we're not creating an oval shape. We're creating like 2 parabolas. So instead of going in towards the center, they're going away from the center. And so that's where the vertex is going to be. So you've got these vertices here and here. And this is called a branch, and this is called a branch. You're going to have these focus points that are going to be out away from the center, where an ellipse is towards the center. You also now have asymptotes, and the asymptotes are not part of the hyperbola, but they define where the hyperbola gets drawn. The nice thing about hyperbolas is you're not going to pick points like we did in parabolas, so it's a little bit different in that respect. Once again, you have the formulas. You do not have to have them memorized. I don't even use them. I just use common sense to get through it all. So I am going to go through a problem. So my first example is x minus 2 squared over 9 minus y plus 1 squared over 16 equals 1. The difference between a hyperbola and an ellipse is this is going to be a minus sign. That's how you know the difference. It's going to start out the same way. So my center is going to be the point 2, negative 1. Sketch my coordinate plane. Mark that point. Now I'm looking at underneath the x is a 9, so the square root of 9 is 3, so I want to go right and left 3. And I remember this because if it's the x, I'm moving right and left. So under the y is a 16. I want to go up and down 4 from the center. That's what's going to create this box here. So I'm just going to draw that. It's a dashed line. It is not part of the hyperbola. If somebody draws it as a solid line, I do take off points. And I want to connect corner to corner. Those are my asymptotes. So I'm making diagonals going through the corners. And these are asymptotes. They are dashed lines. And I am using a straight edge. Now from here, I have to think. If the x is first, this hyperbola is going open to this side. So I start at this vertex, and I go to the side. And I do not cross the asymptotes, I kind of just approach them. And I go in this same direction as well. I didn't do it right. I didn't go down 4. And you were probably thinking that. I would go 1, 2, 3, 4. It goes down to here. So mine looks a little bit odd. During the live lesson, I'll make sure I do it correctly. I'll do a different example. So my vertices are here and here. 3 to the left and 3 to the right of the center. So my vertices are going to be the points 5, negative 1, and negative 1, negative 1. My focus points are going to be outside in here. So I have to figure out that distance c from the center. So for the foci, I've got c squared is equal to a squared plus b squared. Actually, a is always first. I don't know what I'm doing. So C is going to equal 5. So I have to go 5 from the center. 1, 2, 3, 4, 5. Here's a focus point. That point there is -3, -1. Then I have to go 5 from the center to the right. 1, 2, 3, 4, 5. It's right here. So that is the point 7, -1. My asymptotes, I do tend to use the formulas for that. So it's always going to be y equals k plus or minus. So y equals -1 plus or minus. In this case, I want the b over the a. B is going to be 4, a is going to be 3. And then x minus h. And there's everything for that hyperbola. On the back of your notes, there's a hyperbola with a vertical transverse axis. And once again, just because your book didn't have a good picture, all I did was take the one on the front and I just rotated it. Not the best thing in the world, but you get the idea. Now what happens with this one, before I go through the example, this is opening up and down. So what happens with the change of the equation is y minus k becomes before the x minus h. There's still a minus sign there. A and b do not change. So my example I have is y minus 6 squared minus x plus 3 squared over 25 equals 1. So just be careful when you're doing this kind. My center is going to be the point -3, 6. Then I'm going to go ahead and draw everything I need. Underneath the x is a 25, so I have to go right and left 5. Underneath the y, I don't have anything. But if I don't have anything, that means there's a 1 there. So I'm going to go up 1 and down 1. I'm going to use straight edge. And just because I'm not using graph paper, my scale is not exactly perfect. Make my diagonals. Because the y is first, this is going to open up. So there's the vertex right here, and I'm going up. Here's the vertex, I'm going down. I go up towards the asymptotes and don't cross it. So my vertices are right here. So that is the point -3, 5, or -3, 7. And this one here is the point -3, 5. I'm going to look for my focus points. So c squared is equal to a squared plus b squared, so 1 plus 25. So c is going to equal the square root of 26, which is just a little bit over 5. So that means I have to go up just a little bit over 5 from here, or from the center. 1, 2, 3, 4, 5, about right there. And down from the center, 5. 1, let's see, 1, 2, 3, 4, 5, about right here. My scale is bothering me a little bit. It's hard to see. So then this focus point here is going to be the point -3, and then 6 plus the square root of 26. This focus point here is going to be -3, 6 minus the square root of 26. And my asymptotes, y equals k in this case is 6, plus or minus a over b. A is always the first one, b would be 5, x minus h, so x plus 3, and there's my asymptote. And I'll do more with these during the live lessons.